All right, Warhawks, this is Mr. Tipton. Let's do some trigonometry today. Today we're doing Chapter 9.2, tangent ratios, and not going to be a whole lot of notes to write down, more examples to write down. In Chapter 9.2, we're just dealing with tangent. We also have sine and cosine, but in this part of the chapter, it just deals with tangent first. Okay, so your tangent ratio is your opposite over the adjacent. We talk about SOHCAHTOA in class. TOA is the part that talks about tangent. You've got tangent is opposite over adjacent. Now your book gives you cotangent, which in honesty you really don't need cotangent because you could always just use tangent. But technically it is good to know what the cotangent is. The cotangent is just the reciprocal. So I'll show you what we mean here. So when I'm going to look at angle A. It's going to be my reference angle, and I want to enter the tangent ratio for angle A. So the tangent of A is going to equal the opposite side of A over the adjacent side. We talked about this in class, but you can see that 4 is the side that's opposite of A. It's across from it. And 3 is the adjacent side. Remember, 5 is the hypotenuse, so we call it that. We don't call it adjacent. So tangent of A would be 4 over 3. Well, we could also have the cotangent of A. We abbreviate that COT. Cotangent of A would just be the reciprocal of that. It's the adjacent over the opposite. So sometimes they may give you the cotangent. Just know that you flip it over to turn it back into the tangent. So cotangent of A is going to be adjacent over opposite, which is going to be 3 over 4. But again, I'm much more focused on tangent than cotangent, but your book does talk about it in some of the questions. Now, let's look at solving for a missing side. We kind of did this in class, but here we have angle A. That's my reference angle because that's the angle they've given me. So I see that X is opposite and 5 is adjacent. So since I have opposite and adjacent, that means I'm going to use tangent. Tangent is opposite over adjacent. So I say tangent. Instead of saying A, I'm going to actually list the angle. Tangent of 51 equals the opposite side over the adjacent side, 5. Now, here's the rule. If X is up high, we multiply. Now, what I mean by that is X is on top of our fraction. If X is up high, we multiply. It rhymes. Should be easy. And we did this in class. You have X divided by 5. So to get rid of that 5, we're going to multiply 5 times tangent 51. Now, in the TI calculators in class, you can enter it just like that. If you're using a different calculator, you might have to do 5 times 51, then hit tan and equals. But if I do 5 times tan 51, I get 5 times tan 51, I'm doing it on my calculator right now, equals 6.17, so I'm going to round it to 6.2 is the answer I get there. And that's reasonable. It's close to 5. And actually, looking at the angles, this is a 51-degree angle, so this would have to be a 29-degree angle here. So this side should be larger because it's across from a larger angle than this side. That's kind of a little extra information can help you understand if you're getting these right. Also, make sure your calculator is always in degree mode to do trigonometry. So that's if X is high. Let's look at an example where X is down low. So this time C is going to be my reference angle. 9 is the opposite. X is the adjacent side. So notice how when I write this ratio, it's going to be tangent of 25 equals opposite, which is 9, over adjacent, which is X. Now this time X is down low. When X is down low, we want to switch these two things places. So X equals 9 divided by tan 25. And you can enter it into your calculator just like that if you're using the TI calculators. If you're using a different calculator that doesn't, you're not able to enter it like this. You have to do 9 divided by 25 and then hit tan and then equals. But if I do 9 divided by tan 25, I get an answer that X equals 19.3. Now that seems a little high. However, if I look at the angles here, this is a 25-degree angle. So this side should definitely be smaller than this side because this would be a 55-degree angle. So that's going to make that larger. Okay? So there's how you do it. If x is down low, we switch those two things places and divide. Now we get to the last case scenario. So here's my angle. It's the one I'm looking for. 11 is opposite. 6 is adjacent. So again, opposite, adjacent. I'm going to use tangent. So I say tangent. I don't have the angle measure, so I'm just going to enter x equals opposite 11 over adjacent 6. Okay, now this is the tricky part. It says that we want to use tan minus 1. Now, on your calculator, this is not a button, it's a secondary function, which means I'll probably have to hit second before I hit tangent, and that activates the tan negative 1. We also call this inverse tangent. But we can enter it just like this. It's actually really easy, but a lot of times people get confused. In my calculator, I'm going to enter tan negative 1. If you're using the TIs, a parenthesis will pop up. In there, I just want to enter this division problem, 11 divided by 6, and I'll get the right answer. Now, if you're using a different calculator, you'll actually have to do it in reverse. You'll do 11 divided by 6 equals, and then hit second tan negative 1, and it'll give you your answer. So if you're trying these to see if you know how to do it in a calculator, make sure your answer matches mine. So I hit second tan, inverse tan pops up. I do 11 divided by 6, and I get my answer of 61.4 degrees. Now remember, this is an angle, so your answer should always be somewhere between 1 and 90, so greater than 0 but less than 90, and that fits in there. And then I would actually also know this angle. I could use tan. I do tan 6 over 11 or inverse tan 6 over 11. It would give me that angle as well. All right, we'll see you in class. Write down these examples, watch the video, and we'll talk to you later.